The thing that you're going to do once you have your displacement diagram up there is you are going to go and take the minimum displacement, which is the bottom part of your displacement diagram, and you're going to project it across the side of your page using a construction line. Then you're going to go and mark off a point somewhere on that construction line, making sure that you have enough space to be able to draw in a circle that will have a radius of whatever your displacement, maximum displacement is. So if your maximum displacement is 60 millimeters, add on another 20 millimeters and make sure that you've got enough space to draw a circle of approximately 80 millimeters radius. Okay, so when you draw the circle, you don't have what's happened to some people already, and that's that the circle hits into the displacement diagram. Once you've done that, you made that marker on your question paper, you should be given a little drawing which looks like this, which shows the follower, and then gives you a distance between the end of the follower and the center point of the cap. Okay? If you've been given that, then you can note, okay, they normally study that there, that would be about 15 millimeters, and the radius of that could be 10 millimeters. You then take those measurements, and you'll measure that 15 millimeters, which is at the end of your follower, down from that point that you made on the line that you extended from the bottom of your displacement diagram. So you'll go and mark that 15 millimeters down, make a mark. That is now the center point of that circle, which you then go and draw around there, and that is the shaft that goes through the cap. Once you've done that, you can now go take your compass. Well, before you take your compass, take the top point, your maximum displacement point, and project that straight across. And then you take your compass, put the pointed end of your compass on the center point there, open it up so that it touches the very edge of that construction line that you've drawn there, and then draw a big circle around that point so that you've got that. Then you're done with that little diagram. Now you need to go and break up that circle, which is where your cam is going to be drawn within that circle. You break up that circle according to the breakup that they've given you in the beginning of the question for the horizontal displacement. If they've told you that you must use 20-degree intervals, then you're going to break this up into 20-degree intervals. If they've told you 30-degree intervals, that will be broken up into 30-degree intervals, etc. If it's 15 degrees, the same thing. If one small part of this, for instance, this acceleration and retardation movement over there, if you've used a different set of angles for that, so let's say that the entire displacement diagram was broken up into 20-degree intervals, but for this part here, to get an even amount of parts, you have to break it up into 15-degree intervals. Then for the distance between 0 and 160 degrees on this circle, you're going to have to break up that part into 15-degree intervals to match this circle with that horizontal displacement. So the entire thing is you've got to make sure that all of those degrees there are indicated on this circle. That circle has to match your horizontal displacement. If it doesn't, you're going to have problems. Okay, so if I go and quickly break that up, I'm going to do it as best as I can, freehand. I'm going to do one little line at a time here, so I can explain each one. If they tell you that your cam, of course, moves in a clockwise or anti-clockwise direction, you always label in the opposite direction to which the cam turns. So let's say for this one, that this cam is a cam that turns clockwise. We will therefore label anti-clockwise. So that will be 0 degrees. That will be 20. 40, 60, I'm going to need another one, 80. Okay, that over there is not inconsequential because I do not have a 90-degree mark. It goes from 80 to 100. Okay, so you're going to label it there anti-clockwise because you have a clockwise turning cam. Then, step by step, you're going to take every single point where your lines from your horizontal have been projected up. When those lines go and hit into the displacement diagram that you've drawn, you're going to go and make sure that you clearly understand where those intersection points are. I'm going to mark them with slightly big dots so that you can see them nice and clearly. Please do not do this on your displacement diagram when you draw it out. Each of those nice big dots that I've made now are the points that you're going to project across, and those dots there are going to form points on your cam, which will then form the points that you have to join up to get the shape of your cam. So we start with that point over there right at the bottom, and you're going to take your ruler and you're going to project it across right across until it hits the center point or center line that I've drawn in over there. Until it hits that center line, you're going to mark that as well, and then go and take your compass, place your compass point on the center point of your cam, open it up to where that first dot over there has been made, which came from your displacement diagram over here. And then you're going to take your compass and you're going to make an arc onto the first angled line that it hits into, which represents your 20-degree mark, because that point over there was on the 20-degree mark. So that point there must correspond with that point over there of the 20-degree line. And that's the first point now of your cam. Then you do it again. You take the next point. Project that right across. I get that straight. Project that right across where that point hits that vertical center line again. Mark that, and then take your compass, put your compass point there, and again make an arc from that point onto the next degree line, which is your 40-degree line, which must match up here with that 40 degrees on your horizontal. So that point over there is now that point over there, which is the next point on your cam. And then we do it again. Project the next line across. Again onto that center line. And again, from that center line, you take your compass, place your compass point there, and make an arc across onto the next line, and that gives you your next point of your cam. You keep on doing that exact same process for every single one of those points, running all the way up and all the way back down again. And you'll get a whole bunch of points which will form in places around your cam, up to a maximum displacement, and then coming back down. And your last point, your very last point, has to end right over there. Okay, that last point must end in line with the bottom part of your displacement diagram. And if you go and then take your French curves and join all of those points up that you found, that will then form your cam. But that isn't finished yet. You have to remember a couple of things. You have to make sure that for that circle over there, which is the shaft which goes through the cam, that you have sectioned it at a 45-degree angle. You have to make sure that either over here or at the top over here, you have put in an arrow to indicate the direction of the cam. And you need to make sure that all of your labeling has been put in all the way around. And please note that the only things here that are dark lines is everything that I've now drawn in green. So that line there and there can be dark. The center part of your cam is dark with the section lines. The arrows are dark, and then the actual cam itself. Everything else is going to be in construction. Okay, that's explanation.